everybody, and welcome back to the Dark Reading News Desk. I'm Becky Bracken, editor with Dark Reading, and now I would like to welcome Juhee Kim, PhD student at Seoul National University, who is here at Black Hat presenting on how to bypass ARM's memory tagging extension with a side channel attack, and showing how to bypass MTE in the Chrome browser. Welcome, thank you for joining us.
Hello, thank you for inviting me.
Of course. Now I have to confess, I'm not 100% sure what we're talking about here. This seems pretty technical to me. So for my benefit and the benefit of the audience, what are you talking about? What is ARM memory tagging extension?
I found a security attack against ARM's memory tagging extension, so-called MTE. And MTE is a hardware-based defense technique. It basically detects memory corruption by hardware, and it's already available in the recent Pixel devices. And Linux kernel and Google Chrome, they developed the security solutions based on MTE.
Okay, and so that's the memory tagging extension. So what was the vulnerability that you found that enabled the side channel attack?
When we exploited this speculative execution to trigger the MTE tag track. I mean, the MTE basically operates by comparing the pointer's tag with the memory's tag, and the tag usually are created randomly, so that we need to leak the random tag to exploit the memory corruption to bypass MTE. And what we did is we exploited this speculative execution and cache side channel to leak the MTE tag and bypass the MTE.
And so what was the result of that? What would an attacker be able to do with that sort of vulnerability? Without our so-called tag leakage gadgets, when the attacker triggers the memory corruption attack, the program crashes. But with our tag leakage gadget, we can avoid crashing the program and bypass MTE. We can trigger memory corruption as if there is no MTE. So memory corruption, so when you're triggering memory corruption, what are you injecting? Are you poisoning memory with a vulnerability? What does that mean?
So memory corruption is usually when a program runs, there is memory object and there is a pointer, and usually the pointer should point to the original object that should point to, but memory corruption occurs when the pointer gets corrupted by the attacker somehow by the software bug, and it points to a wrong object. And MTE kind of helps that to have to detect that by hardware.
Do you think that the MTE standard itself needs to be updated, or is this just something you want defenders to be aware of?
For the hardware that is already available, we cannot fix the hardware, but still the software developers can mitigate this issue. We explain how to mitigate it in our paper. Our paper is also archived. And the future memory tagging architectures and future chips can fix these kind of issues. I think the developers weren't aware of this kind of speculative execution attacks when they're designing memory tagging extension. So I think our research kind of provides some guidelines to how to design this memory tagging architecture to truly prevent memory corruption attack.
So what about existing hardware that's out there that doesn't have the benefit of being designed securely? What do you do with that?
For example, in Google Chrome, they actually don't deploy MTE by default, but when they use the MTE, it can actually enhance their security. So In case, if we imagine that Google Chrome deploys MTE for their security, to prevent this our attack, they can create a speculative, speculation-aware sandboxes. They already have the sandbox to isolate the malicious code, but they don't care about the speculative path, so they can fix that.
Interesting. Why did you become interested in this? Why this particular bit of research?
MTE has been many security experts have expected that MTE will gonna invalidate memory corruption attacks, and I questioned whether that is actually true. Whether MTE can actually invalidate every memory corruption attacks. And when the MTE hardware was out, we tested whether they have any side channel issues, and they actually did. So yeah, MTE is not yet perfect mitigation yet, but I think we can improve that later.
And so are you working with developers right now of this hardware and making them aware? Is there some collaboration amongst these hardware developers?
We don't currently we are not currently collaborating with CPU vendors. We did collaborate with Samsung Research. We collaborated with them to find this hardware vulnerability, but they're actually not the CPU vendor.
Who are the vendors that use this?
I think the vendors are the actual CPU chip vendors.
And is that the only standard that exists at this point, the MTE, that is being used in these instances, or are there competing standards?
Competing standards?
Are there other standards that you could use, or is MTE really the only one right now that is being used?
The available hardware, as far as I know, is ARM memory tagging extension, and I've heard that some RISC-based architecture provide memory tagging features, but I think they're not widely used.
Right.
ARM MTE is the first widely used
The
version.
more widely used. What do you want beyond a doubling down of security in the development process and in the manufacturing process? I understand that. But what do you want the takeaway to be for the cybersecurity community? What do you want them to know and do as a result of your work?
I want them to know the current MTE hardware does not provide the security guarantee as we expected, but I suggest that the hardware vendors to keep in mind that their attackers always find ways to break things, and speculative execution and CPU side channels are commonly considered attack vectors. And even though there exists this kind of side channel issues, software developers can be aware. They can also be aware of this issue and can mitigate their products to prevent any bypass of their security defenses.
That makes sense. Can you tell us where you will be? You're presenting tomorrow? Is that right?
Yes.
Tell our audience where they can catch your briefing.
My briefing will be at Oceanside 8.
At what time?
At 2:30 p.m.
2:30.
Thursday. Yeah.
Okay.
Tomorrow.
Wonderful. Well, good luck, and thank you so much, Juhee Kim, PhD student, for joining us and for sharing your work with us. We very much appreciate it.
Thank you.
Thank you. Good luck.